So next up on our project is when to stream, analyzing the results. So let's take a look and see what happened on our script. Previously, the week before, whenever the programming community went up or down from the second page of results, the first page of second page, we were hard-coded on the second page. Whenever it moved around from the second page of results, it didn't get any data, and the cloud function ran for 60 seconds and eventually crashed, which is a bummer. But it didn't run very often, so it was not that costly. But since then, it's actually run much better. So if we expand out all of the data on where Twitch Tracker is filing data away, we can see that it is big enough that it made my browser grumpy. So let's try loading that. Let's try taking another peek at that data. Otherwise, I'll just pull it in through the REST API. But it's been running for about a week. So we should have a week's worth of hours, which is, oh wow. Killed that tab. It's a lot of data, I guess. I tried to force it to load at once. But yeah, there's a bunch of them there now. And we have them roughly every hour. So it looks like the changes we made actually worked. We can see this is it probably moving down to the 4th page. And we also probably have the more popular times. Oh wow. 34 people watching, 8 people streaming. So apparently it gets pretty light sometimes. Around 3 o'clock in the morning, GMT time. So let's take all this data out and let's just dump it into Sheets. So if I want to pull JSON into Sheets, I could write some code that will go and remunge this and put it into delimited stuff. Maybe there's a better way. So let's ask the internet if there's an easier way. Is there an how to import JSON data into Google Sheets in less than 5 minutes? We can use AppScript. That's cool. Oh, there's an import JSON function. Oh, that's cool. It's built into Sheets already. I bet we can point this if we open up read access. Oh no, this is a script. Okay, so a script that adds a function, import JSON. That's pretty cool. Let's take a look at this. And this, of course, is a situation where you always need to be a little bit cautious, because whenever you pull data from an external system into a spreadsheet, you're opening yourself up to spreadsheet injection vulnerabilities. I know, crazy, isn't it? The script is not actively maintained. I wrote a quick for a project in 2012. Hey, it might still work though. And it's on GitHub too. So we can take a peek at it and see if it is worth saving our time. Otherwise, we can write a couple lines of code to remunge this. Let's take a look at, and it is under GPL version 3. So the license is clear. And it does lots of sanitization and stuff. Oh, this is pretty nice. I think that I'm just going to do the one-liner approach, though. And let's see if there's any other results that stand out. A bunch of other like scripts and stuff like that. We're just going to do it with stupid one-liners. So we're going to go back up to the database. We're going to release our security rules and make this world readable. Because what I could do is I could use an authenticated client to do the reads and that kind of stuff. But I'm going to be a little bit lazy today. Whoops. Okay, there's my terminal. Need a terminal to do stuff. So there is, here's the code where we're doing our work. I'm just going to pull it down and do some like ugly stuff. Try again. This is awkward. Security rules page, there it goes. Okay, so right now it's locked down entirely, so you can only access it from, in our case we're we're accessing it from a cloud function, which is running as a privileged client. So I just made the security rules. Basically, nobody has access unless they're a privileged administrator. Like I'm using the admin SDK for the cloud function. So let's just change this to true. Now everybody can read the data. So all of you who are fast at URL hacking can go up and read the data. Feel free to. We're going to go grab this URL, and we're just going to pull it down locally with curl. Oh, there's the data CSV right there. Your data. Curl-o, let's pull it down from the REST API. There we have it, 21 kilobytes of data in .json. A strange file name it picked, curl-o. Oh, well, obviously, because the end of the URL, curl-o just pulls that off. So I should have piped it to a file instead of using -o. Anyway, so this is a snapshot from the 31st of October, Halloween. Because I'm going to leave the script running. But, so I just want to get the snapshot for now. Let's take a look at it. One huge line. Okay, so it kind of freaked out. Oh, I have my arguments in the wrong order, but that's okay. Cool, okay, so we have lots of data in there. So let's just do some shell smashing on it until we get the data we want. We'll force it into roughly comma delimited text, which is pretty easy for us because of the way we structured it. So where do we want to split it? We probably want to split it on these keys or curly braces. Okay, so first let's just make it pretty. So cat, our file, we want to pipe that over to python-mjson.tool to make it pretty. This is kind of my favorite way to kind of mudge around with data. Okay, so now we have some JSON. It's pretty. Yay! So what do we don't actually care about these IDs. We just want to get these three onto a single line, comma delimited, and then we want to get rid of the keys. So what's the easiest way for me to smash all those onto a single line? So I'll use Vim. So we'll pull it up in Vim, and we'll do our RegEx hacking here. Go to the end. There's a better key for that. Then what we want to do is we want to do a search and replace of So what I'm going to do now is I'm just going to kind of use a RegEx to smash these all into one line, and then I'll use a regular expression to remove the keys. Maybe I should remove the keys first. Dot star, open curly brace. Oh, but I can probably use the curly braces to determine the beginning of it. No, I'll just remove it. There, got rid of those. Now we can do, regexes are great. Dot star, close curly brace, dot star \n. Global. Cool, okay, so now we have just the data we care about. And now what we want to do is, oh, somehow I've managed to get it to highlight those. So now what we want to do is we want to, it's angry because it's trying to do JSON syntax highlighting on something that is no longer JSON. And it's grumpy because there's no commas after viewers. So now what we want to do is we want to get channels. Star. Okay. So how do I want to do this? So channels, it's going to give me a number. So I want to do a multi-line regex match on this. Delimited by, it ends with channels. So what I want is I want every third new line, every second and every third new line to go away. So there's probably a really easy way to do this. So \n, and then a not new line, and then a bunch of those. Well, the first one doesn't have a new line, so we'll do channels, \n, not a new line. Then what we want is colon space and then 0 through 9. So I actually don't care about any of that stuff. So channels is there. We'll do dot star channels, then we get numbers 0 through 9 star, and that is, I think I'll look before I leap, so I'll just do a match first. 0 to 9, comma, \n. Then we have a timestamp, which I do want to keep. And this is going to be timestamp. So do I want to, I can probably just do not quotes. So not quotes, star quote, comma, \n. And the thing I actually want is this part. And then this will go to viewers. Viewers, there's probably a much easier way to do this using like a real parser, but I don't know. I spent too long building Perl stuff, I guess. And this is another numeric one, 0 through 9. And this one does not have it after it has a new line at the end. Pattern not found. Not terribly surprising. Okay, so which part is not found? Let's just do this a chunk at a time. So can I find channels? No. Is that because the parentheses have different meaning in this context? Yes. Okay, let's just try doing this all as a big ol' nasty giant match. Because apparently the parentheses, when you're using them in a regular finder instead of other selector, make things sad. So this is, what is this going to be? \2, \2, \3, and then, no, that didn't work either. Okay, so let's try doing this one at a time. So, oh, these tabs are spaces, okay. We'll incrementally do this. Instead of trying to do it in one big ol', there we go, we got rid of all the spaces. We'll do this incrementally in a bunch of different passes. So I probably don't want to get rid of all of these identifiers, but I can probably get rid of some. Because I'll need some of them as markers to do my other stuff. So first of all, does that match viewers? Yes, it does. So now that I've matched viewers, I want to match viewers and then 0 through 9, star. Does that replace? Hey, it totally worked. Okay. So let's undo that, go back to line 1. And then what we will do is we will grab these. And then this should be. So why are my parentheses not matching? Do I need to escape these? Yes, apparently I did. Okay, so that was the problem. So, so that's putting it on. So are viewers before or after channels? Viewers are before, viewers are at the very end of the line. So I do not want to remove that trailing new line. I want to have a comma ahead of them and I want to remove the leading new line. Yay! Okay. And then we have a double comma there, but we can clean that up later. Let's do the same thing for timestamps. This is also the way not to do anything ever, but I will do it anyway. Oops. It's the way I deal with munging some of this data in a way I'm never going to reuse again. Although I'm probably actually going to reuse this again. I should probably do it better, but whatever. Okay, so timestamp comes, it has a quote, and then it has a quoted date, which is not 0 through 9. It is a not quote. And then it ends with a quote, and then a comma. And then what we want to replace that with is that. Okay. Hey, it kind of worked, although I probably want to quote that field. So let's undo it, and let's add quotes around our thingamajig. There we go, because it's good to have stuff quoted in CSV. And then finally, we need to get rid of channels and then clean up those double commas. So channels is gone. Hey, we have roughly comma separated values. So comma space, it should actually be a comma in the CSV spec. So that looks like CSV data. Why not? Okay, so we have our pretty JSON-like thing. Let's go take a look at this. Let's try importing this into a spreadsheet and see what happens. So let's go ahead and go to sheets.google.com. I'm gonna make a new sheet. Call it Twitch live streaming stuff. Oh, when to stream. I have a name for this project. And this is the munge data from. So let's go import that. File import. And then I'm going to open this up. Have this data here. Let me go upload. And I can just drag a file in from my computer. And this is actually not a JSON file. This is actually CSV now. Use CSV. And hey, is it still the same? Yay! Hey, the preview thing knows how to read it. Maybe this will too. We're going to insert into exist current sheet. We will detect automatically separator, and hey, we have stuff. So the one thing I'm wondering about, because I want to do a time series chart, is does, first let's add a header row. So insert row above. So channels, when, timestamp, and viewers. So let's make this bigger. So let's make this bigger so it's easier for all of you to see. Okay, so here's our data. I'll drag the timestamp over to there. We have our channels, we have our viewers. And hey, look, it's like data-like stuff. So one thing I'm curious about is will it understand this as a date? So if I go over and say, hey, it's a date. No, it didn't understand it. That's a bit of a bummer. I was hoping it would understand these. So, but maybe if I tell them it's a data format. How about a date time? Nope, still doesn't understand that format. What if I remove one of those things? Format, number, date time. Nope. Maybe it's the decimal it doesn't like. Maybe it needs a space instead of a T. Hey, that figured it out. That got it figured out. Okay, so what if I just remove the T on that one? Format, number, date time. So it doesn't like the Z. It doesn't like the Z or the T. So those are the only T's and Z's anywhere in the spreadsheet. So I could go back and do it with a regular expression, but I'm just going to use regular hold search and replace. So the T's we're going to replace with space, and the Z's we're going to replace with nothing. And hey, now it understands what they are. That makes me feel a little yucky inside. But hey, it works. It's amazing what you can actually just accomplish with just a simple search and replace. So now that we have that, let's do a little format, number, date time. They're all in a common format now. And we have 233 samples, so we can build a little time series chart. I haven't done a chart in a spreadsheet in a long time, which is probably a better command line charting tool I should be using, but I'm just going to say, hey, give me a chart. Oh my gosh, it kind of worked right away. That's pretty cool. So we have the channels and the viewers over a time series. Oh, wait. There was another T in there. Okay. So here is our time series chart. And what we can see is that there's been a huge drop in people in the programming community recently. It's much more spiky. And that's probably because I was losing out on these bottom samples and the topmost samples. That's really interesting. Okay, so let's change this over to a logarithmic chart. Can I do that? I would love the vertical axis to be logarithmic. Yay, we totally can. Okay, so that kind of gives us an idea of the ratio between these in a logarithmic sense. And so basically it tells me that the number of people streaming, these are the real results, the number of people streaming over time. We can disregard this whole chunk. So I'm actually going to go back and cut everything away before the 24th because that data is all garbage because we're missing samples. So I'm going to go get rid of all of this stuff. And then I'll just delete all these rows. Delete rows. Data's mashed up there. Okay. So this is what we actually have as a result. This is a logarithmic scale graph, and it shows us that, yes, not surprisingly, internet behaviors kind of track each other. But the number of viewers fluctuates a lot more than the number of people who are streaming. So what this seems to imply is that sometime between like 19 and 2100 hours GMT time is the time when there are hundreds of people watching, versus on the troughs, there are as few as 36 people watching at 9 a.m. GMT, which I don't actually know what that is for an E. GMT in PT, PDT, PT. I'm PDT right now. So that's 2 a.m. my time is a bad time to stream. But right around 1900 GMT, so that's 7 p.m. I don't know, we'll understand 1900? I hope so. No, it didn't. 7 p.m. GMT or 12 p.m. So going from that, from like 11 a.m., hey, I'm actually hitting right around the best times to go. So it sounds like for me, all the way down to like this peak is right around 2200 hours. This peak was at 1600 hours with another peak at, okay. But yeah, it seems like 2200 hours, 2200 hours. It's almost always about 2200 hours. Interesting. Oh yeah, I do 24-hour time. I'm one of those weirdos. So 2200 hours is 10 p.m. GMT, which is also 3 p.m. So which means I should probably be shifting my stream a little bit later to get access to a wider audience if that was one of my goals. And that might be something I do as a result of this. So it seems like starting around lunchtime in San Francisco and going into the early afternoon, which seems to make a lot of sense, because that is the time when a lot of East Coasters who go to work earlier and get off work earlier are getting home and decide they want to watch coding when they first get home. And it's also hitting, that's still a reasonable time in the evening for people in Europe. 2200 hours to 10 p.m. So people are watching some coding streams later. And so there's some interesting spikes here. I wonder if these correspond to particularly popular streamers doing events or something like that. So anyway, that was a good, cursory, non-scientific gut feel analysis, and we do actually have some information on when people like to stream and when people like to watch people stream. Oh my gosh, there were 5 channels at one point, so sad. When people like to watch people stream. That was a very enlightening exercise, and it was a really fun opportunity to play around with Cloud Functions and develop opinions about using promises on realistic problems relative to APIs and stuff, which is cool. Okay, so we have some results. When to stream. I'm going to take a screenshot of this because it's going to go up onto the GitHub repo. IMSAMP. I should probably fix that though, because it still has my channels and viewers. Where did it put IMStamp? So that's the horizontal axis. I should say that around here. But that's those labels. Oh, I can slant them. That's cool. That makes them a little easier to read. Oh, I can make this chart a lot easier to read. I probably just want this to be time, don't I? Oh, I wish I could break this down by date and time, but I don't think this is a sufficiently complicated graphing tool to be able to do that. How do I change that part? IMStamp. When? There we go. And then channels and viewers. And most people actually don't like logarithmic charts. So I'm going to change this back to an absolute chart, because all I really care about is the fact that it doesn't fluctuate that much. So where is that? That was under series. Nope. Charts and axes. Vertical axis. Boop. Log scale gone. Okay, so this basically reveals that like the number of people streaming doesn't really fluctuate all that much. The number of people watching has huge spikes at that time, which I don't know if that was apparent from the previous incarnation of the chart on logarithmic view, but it's cool. Okay, so that'll probably go up into a write-up of this stuff. Yay, and then I'm gonna, I'm not gonna delete this data. I'm gonna leave this running indefinitely, because why not? And then with that, we can move on to the next topic to look into. Let me just keep an eye on my notes real quick. Go back here, make sure I'm not missing anything important to talk about. All right, so let's move on into the next task. We can close on out this Firebase viewer and bring back up our little to-do list. We did the when to stream analyzing the results, and that was tons of fun. We hacked around in Vim with regular expressions. We dumped it into a spreadsheet. I should probably come up with a pipeline with that actually works better and makes a pretty chart. That would be cool. I don't think I'm ever going to do that. I don't think it's worth my time to make a more robust version of that. Yeah, and then we're going to move on into actual coding for CloudSpin v2, coding that is beyond the smattering of RegEx is like splotched about. And let me use the unified name for that project. And we're going to move on back into CloudSpin 2. So we're going to spend some time doing some cleanup, basically moving code around different source repositories. Then I might spend some time kind of working on a general flow diagram, but basically I'm going to dive into an Android app. We're going to discuss, we're just going to do some Android live coding. Sound like fun? I hope so. It's a little bit of a departure from what I've done in the past. Oh yeah, we'll get back to that one later. Let me move that up to the top of this. Boop. Windows Stream design. This one's kind of done for now. This one is kind of done for now. Yay. Yeah, so Windows Stream is done. It is a monstrosity of terrible code. But with any project, you have to kind of decide that point in time, that line in the sand you draw, when that's enough goodness. Because, you know, there is no good code out there, which makes me a little sad. So let's go ahead and move code around like I said I would. So let me pull up this, and let's take a look at the current situation on, where is that code living right now?